Hi students, this is another video on rational expressions, your favorite thing ever. Remember, rational expressions are just fractions. Okay, rational expressions are fractions. And here we're going to be focusing on adding and subtracting fractions with unlike denominators. And the word unlike might be how you feel about fractions. I don't blame you if you dislike them, but we still have to do them anyway, just like you have to do your dishes, right? So unlike denominators means different denominators. Okay, so they have different denominators, and so when they have different denominators, they're a lot harder. Make sure you've already watched my video where I talk about adding and subtracting rational expressions with like denominators, because if they're the same denominator, that's a lot easier. So you want to start with those and then work on these next. Okay, so the basic idea here is we're going to build them to the same denominator and then combine them. Alright, so let's just do this by example, because that's probably the easiest way. Okay, so example, add or subtract as indicated. Add or subtract as indicated. Okay? Or sometimes they'll just say, perform the indicated operation. It means the same thing. And they don't say it, but you always want to simplify. So you always need to simplify. I'll put it in parentheses because it's not actually in the instructions, but you always need to do that whether they tell you or not. Okay, so for example number 1, we're going to be adding a couple of fractions. So we have 25 over 5z plus 49 over 7z. Okay, 25 over 5z plus 49 over 7z. So these are unlike denominators because they're different. So they're not the same denominator. So in order to combine these, we need to build them so that they do have the same denominator. And the way I usually teach it is I say, you want to multiply by what's missing to build to the same denominator. Okay, so build each fraction to the same denominator. Okay, so build each fraction to a common denominator. And the way you do that is you multiply each fraction by whatever it's missing. Okay, so multiply by what is missing. Okay, so when we look at these two fractions, we can figure out what's missing. So with the first denominator we have 5z, and with the second denominator we have 7z. So from the first denominator, we can see that we're missing a 7. So we're going to go ahead and multiply the first fraction by 7 on the top and the bottom. So now for the first fraction we now have a 7 times 5z. So we have a 7, we have a 5, and we have a z. Now if we look at this denominator, what are we missing here? Well, it looks like we already have a 7, we already have a z, but we're missing a 5. So we're going to multiply this other fraction by what it's missing in the denominator, and we can see that it's missing a 5. So we're going to multiply this one by 5 on the top and the bottom. Okay, And then you might want to use a calculator here, or you can just write it out by hand. But 7 times 25 is 125. So let me zoom out a little bit. So here we have 125. It's 175 is what I meant to say. I don't know what I said. It's 175. But once again, you can just type it into your calculator if you don't believe me. So 7 times 25 is 175. Yeah. So we have 175 over 7 times 5z is 35z. Okay. And then for the second fraction, 49 times 5, if you want to be lazy, you can type it in. 49 times 5 is 245. Okay, so we have plus 245 over, once again, 7 times 5 is 35z. And what we did there is we took these two fractions that had different denominators, and we multiply on the top and the bottom by what's missing in the denominator, and then after we do that, then they have the same denominator. Okay, so now we can see that we have the same denominator. And because they have the same denominator, we keep the denominator and we add on the top. Okay, because these are now like fractions. Okay, so on the top we're going to have 175 plus 245. And then we keep the denominator, okay, so we keep the 35z because they're now the same denominator. These are now like fractions with like denominators. So this is all over 35z. Okay, and then once again, for 175 plus 245, you might want to just use a calculator, or you can write it vertically and do it the old-fashioned way. So 175 plus 245 is 420. Okay, so 420. So we have 420 over 35z. Okay, and then you're not done. You still need to simplify this a little bit. And if you're not sure what numbers to divide by, you can look at the last digit here. On the top we have a 0, on the bottom we have a 5. Those are both divisible by 5. So we can divide the top and the bottom by 5. So that's one thing we could do. So let's do that. So if we divide 420 divided by 5, if you're not sure what that is, once again you can jump on your calculator. 420 divided by 5 is 84. So on the top we have 84. And then on the bottom, 35 divided by 5 is 7, because 7 times 5 is 35. So right now we have 84 over 7z. And then I believe 7 goes into 84. And that's in your times tables. But if you don't believe me, just do 84 divided by 7. It's 12. Okay? So that means we still have another common factor, so we can divide the top and the bottom by 7. And so on the top, we're going to get 12. And then on the bottom, the 7s are going to cancel out, and we're just going to get z. Okay, so our answer is actually going to be 12 over z. Okay? And that's actually the whole problem. So that one wasn't too bad. I wish I could say they were all that easy, because that one was really not so bad. So let's take a look at our next example. Okay, so let's do example number 2. Example number 2. So for this next example, we're going to be doing 12a over b minus 7b over 3. Okay, so 12a over b minus 7b over 3. So once again, these don't have the same denominator, so we need to build them to the same denominator. And the way we do that is we multiply by what we're missing in each denominator. So in the first denominator, we can see we have a b, but we don't have a 3. Okay, so we have a b here, but we don't have a 3. So we're missing a 3 here, which means we're going to multiply the first fraction by 3 on the top and the bottom. So we just multiply by what's missing. And then in the second denominator, well, what's missing here? Well, we don't have a b, but we do have a 3. So for this one, we're missing a b. Okay, so we're going to multiply the top and the bottom by b. All right, and that's the hardest part, is just knowing what to multiply by. But again, look for what's missing and multiply by that. So for top left, we have 3 times 12 is 36a. Okay, so we have 36a. And then for top right, we have negative 7. B times b is b squared. So that's going to be minus 7b squared. All over. In the denominator, we have a common denominator of 3 times b. And because they're the same denominator, we can write the numerators both over that common denominator of 3b. Okay, so we have 36a minus 7b squared all over 3b. And I know it looks like you'd be able to cross something out or cancel something out here, but this is actually as simplified as it gets. So you don't want to do anything else here. You can't even really factor the numerator, so there's nothing left to do here. So this is actually going to be our answer. 36a minus 7b squared all over 3b. All right. So I want to do a few more examples of these because these can be challenging. If you do them the right way, if you do them my way, most of them are not that hard because my way is kind of easy to understand. You multiply by what you're missing, but these can get confusing if you kind of forget how to do them. Okay, so for example number 3, let's take a look at another harder problem. So for example number 3, we have 5 over x plus 2 over 3x squared. Okay, so 5 over x plus 2 over 3x squared. So once again, we want to play the same game where we multiply by what we're missing. But this one's a bit harder. So in the first denominator, we have an x, but we don't have a 3, and we also don't have an x squared. So clearly we're going to need to multiply the first one by 3 on the top and the bottom. Right, so we're going to need to multiply by 3. That way we have a 3 in the denominator. And then the question is, well, we have an x here, but we don't have an x squared. So what do I need to multiply this fraction by so that I can get an x squared? And of course the answer is, well, x times x is x squared. So we're going to need to multiply this first fraction by x on the top and the bottom. Okay, because x times x is x squared. So after we do all that, then we're going to have the same denominator. So we're not really missing anything in this other bottom right denominator, so we don't actually need to multiply by anything because we already have a 3 and we have an x squared, so we're good. So the first fraction is now going to become 3 times 5 is 15x. So we have 15x over 3 times x is 3x squared plus 2 over 3x squared. Okay, so we have 15x over 3x squared plus 2 over 3x squared. And now these have the same denominator, so we're going to keep that denominator and we're going to add on the top. So we're going to add the numerators. Okay, so in the numerator we get 15x plus 2. And then in the denominator we keep that denominator, which is 3x squared. And believe it or not, that's the whole problem. You can't cross out the 15 and the 3. I know it looks really tempting, but the reason you can't cross that out is only this first term on the top has a 15. The second term doesn't have anything involving 3, so you can't actually cross those out. And you also can't cross out the x and the x squared because the first term on the top has an x, but the second term doesn't have an x. So you actually can't simplify this anymore. So 15x plus 2 over 3x squared is actually going to be your answer. Okay? And that's actually the whole problem. So those first few problems are not too bad. I'm hoping they aren't too bad for you. And I wanted to do one example of each type of problem that's on your homework, so hopefully you'll be good for it, because this is a challenging topic for a lot of people. Hopefully you'll find my way easy to follow. Okay, so let's do problem number 4. Okay, problem number 4 is 8 over x plus 1 plus 14 over 7x plus 7. Okay, 8 over x plus 1 plus 14 over 7x plus 7. All right, now this one's a little bit trickier because the denominators have more than one term. And the trick with this particular problem is you want to factor the denominators first. That way we can see what's missing. Okay, so the trick here is to factor the denominators first. And then we'll be able to see what is missing, and then we'll be able to multiply by whatever we're missing to build them to a common denominator. Okay, now the denominator on the bottom left can't be factored. X plus 1 is just the way it is. There's nothing you can do to factor that. So we're just going to leave that as x plus 1. But for the bottom right, the 7x plus 7, we actually can factor out a common factor of 7. So we can factor out the 7 there. All right, that's our common factor. Okay, so we have 8 over x plus 1 plus 14 over 7 times x plus 1. Okay, so we have 8 over x plus 1 plus 14 over 7 times x plus 1. All I did there was I factored the bottom right corner, and I factored out the GCF, which was 7. Okay, so now we've factored the denominators, so now we can multiply by what is missing. Okay, so multiply by what is missing, by what's missing. My writing is getting messy. Or not messy, but just erratic. Okay. So now that it's factored, it's easy to see what's missing. So both denominators have an x plus 1, so we're good there. But the first denominator does not have a 7, and the second denominator does have a 7. So here from the first denominator, we can see that we are missing a 7. So we're going to multiply the first fraction by 7 on the top and the bottom. Okay, and that's what I mean by multiplying by what's missing, is whatever's missing there, you have to multiply it on the top and the bottom. Okay, so 7 times 8 is 56. So we have 56 plus 14 on the top. And then on the bottom, now we have a common denominator of 7 times x plus 1. Okay, so our denominator is going to be 7 times the quantity x plus 1. Now in our numerator, of course, we can combine 56 plus 14. So 56 plus 14 is going to be 70. If you don't believe me, you can write it out or use a calculator. 56 plus 14 is 70. Okay, so after we combine those, 56 plus 14, we have 70 divided by 7 times the quantity x plus 1. Okay, and so for the 70 and the 7, we can see that we have a common factor of 7. So we can actually divide the numerator and the denominator by 7. So after we divide both of those by 7, then we're going to get to the end. So on the top, 70 divided by 7 is 10. And then on the bottom, the 7's cancel. So in the denominator, we actually just end up with x plus 1. So our final answer is going to be 10 over x plus 1. Okay? And that's the whole problem for number 3. I believe we just did number 3. Okay, now, that one was a little bit harder, but still hopefully not too bad. I'm sorry, that was number 4. That was example number 4. That was not an example number 3. I'm getting old. Okay, so example number 4 we just finished. So let's go ahead and do example number 5. Okay, so for example number 5, like I was saying, the last one wasn't too bad. This next one is a little bit harder. There's more factoring to do here. So for this next problem, for number 5, we actually have 4 over x plus 3, okay, minus 3x over x squared minus 9. Okay, so 4 over x plus 3 minus 3x over x squared minus 9. So like I said, the trick with these is when you have a complicated denominator, like this x squared minus 9 on the bottom right, the first thing you need to do is factor. Okay, so if we factor this x squared minus 9, that's the same as x squared minus 3 squared. So that's going to factor using the difference of squares. Okay, so difference of squares. And remember, for the difference of squares, if you have something squared minus something else squared, like here we have x squared minus 3 squared, that's going to factor as x minus 3 times x plus 3. Okay, x minus 3 times x plus 3. And then over here we still have a 4 over x plus 3. And then minus 3x over this. And then I'm going to give myself some room over here so that I can multiply by what's missing. So our first fraction was 4 over x plus 3. And I'm going to put parentheses around the x plus 3 so we can think of it as a distinct factor. Alright, so now we can look at this. Now that we've factored the bottom right corner, now we can look at this and we can see what we're missing. So if we look on the bottom right corner, we have an x minus 3 and an x plus 3. But in the bottom left corner, we can see that we're actually missing an x minus 3. Okay, so down here we're missing an x minus 3. We only have an x plus 3, but we don't have an x minus 3. So that's what we're missing. So actually, let me rewrite this so it looks better. Okay, so this one was 4 over x plus 3. And so since we're missing an x minus 3, we're going to go ahead and multiply the top and the bottom by x minus 3. Okay? Alright, and then after we do that, then now these have the same denominator. So since they have the same denominator, x minus 3 times x plus 3, we're going to keep that denominator and we're going to combine them on the top. Okay, so on the top we have x minus 3 times 4 minus 3x. And then on the bottom, now we have a common denominator of x minus 3 times x plus 3. And of course we still aren't done here because we can still simplify. So what can we actually simplify here? Well, the first thing I would do is on the top left, I would distribute this 4. Okay, so we're going to distribute the 4 to each of those terms on the top left. So that's going to give us 4x minus 12 minus 3x. And then in our denominator, we don't want to multiply it out. We want to just leave it factored. So we're going to leave it as x minus 3 times x plus 3. Okay, And then in the numerator, now we actually have like terms. So the like terms up here are actually going to be 4x and negative 3x. Okay, so 4x minus 3x is 1x, which is just x. Okay, so in the numerator, we just have x minus 12. And then in the denominator, we have x minus 3 times x plus 3. And believe it or not, this is actually all they want you to do. This is literally all you have to do here. So this is going to be our answer. And you can't cross out the 12 with the 3's because x minus 12 isn't exactly the same factor as x minus 3 or x plus 3. So we just leave it this way. Okay, so our answer is x minus 12 over x minus 3 times x plus 3. And that one is the second hardest problem in your homework, the one that we just did there. Keep in mind yours will be along the same lines, it'll just be with different numbers. Okay, so I wanted to do one more, which is actually easier for me than the one we just did, but some people might find it harder just because it can be confusing. So the one we just did was number 5, is that right? I don't know, my memory is seriously bad, but that was number 5. So now we're going to be doing example number 6. Okay, so for example number 6, we have 2 over 7x plus 5 over x plus 9. Okay, 2 over 7x plus 5 over x plus 9. So here we need to multiply by whatever we're missing. Now, there's nothing to factor here, so that's already done. So that's something easier about this problem. So I'm going to put parentheses around the x plus 9. Now the tricky part about this problem is not so much that it's a hard problem, it just confuses people because they're not sure what's missing here exactly. So when we look in the first denominator, we have a 7 and we have an x. And then in the second denominator, we have an x plus 9. So for starters, you need to realize that x and x plus 9 are actually different factors. They're not considered the same thing. Okay, so x and x plus 9 are different factors. So what I mean by that is even though they both have an x, they are not the same factor. So when I say what's missing, we need to multiply by what's missing. X and x plus 9 are considered two different things. So they don't have anything in common, which means we need to treat them as separate factors. So what are we missing in the first denominator then? Well, we have a 7, we have an x, but we're missing an x plus 9. So we're going to multiply the first fraction by x plus 9 on the top and the bottom. Okay, that's what's missing there. Okay, and then for the second fraction, what are we missing there? Well, once again, x and x plus 9 are considered different factors, and we're also missing a 7. So I'm going to go ahead and multiply this second fraction by 7x on the top and the bottom. And like I said, this isn't actually a hard problem, but what's hard about it for some people is if they just don't know how it works. It can be confusing, because when you see an x and an x plus 9, you would think that they would have an x in common, but they actually don't, because x plus 9 has two terms, so it's considered something different from x. Okay, so that was the main trick there. If you know the trick, the rest of the problem is actually not that bad. Okay, so we now have a common denominator. We now have a common denominator of 7x times x plus 9. I mean, I wrote them in a different order, but remember when you're multiplying, the order does not matter. Okay, so now we can combine these. Since we're adding, we're going to write these both over the same denominator of 7x times x plus 9. Okay, so these are both over 7x times x plus 9. All right, and then in the numerators, we have 2 times x plus 9 plus 5 times 7x. Okay, so 2 times x plus 9 plus 5 times 7x. Okay, and what do we have to do here? Well, for top left, we need to distribute this 2 to each of those terms. So we have 2 times x plus 2 times 9. Right, so distributing that 2 on the top left, we get 2x plus 2 times 9 is 18. And then top right, 5 times 7 is 35x. So for top right, we have plus 35x. Okay, and this whole thing is all over 7x times a quantity, x plus 9. Okay, and then all that's left to do here is to combine the 2x and the 35x. And then, of course, if there's anything that's going to cancel out, we're going to need to do that at the end. So combining the 2x and the 35x on the top, 2x plus 35x is 37x. Okay, so we have 37x plus 18 all over 7x times x plus 9. Okay, now if you look at 37x and 18, those don't have any common factors because 18 is 6 and 3, and I believe 37 is a prime number. Don't quote me on that, but I certainly don't. We never see 37 in our times tables, so it's not a multiple of 3 or 6 or 9 or 18. So since they don't have any common factors, we can't factor out a GCF. Okay, so this is going to be our answer. 37x plus 18 all over 7x times x plus 9. Okay, and that's the last type of problem on your homework. So thanks for watching the video, and we're done.